Hello everyone, welcome to Robert Morris University Math 0900, Chapter 5, Lesson 7. Excuse me, this is Brianne Pernick. In this lesson, we are going to learn how to solve quadratic equations by factoring. In the last several lessons in this chapter, we have focused on various methods to factor quadratic expressions. We've learned that we should always try to factor out a GCF as our first step. We have learned to use the C method, the AC method, factoring by grouping, factoring difference of squares, and also factoring perfect square trinomials. The big shebang of this whole chapter is putting that information to use in order to solve a quadratic equation by using factoring. I often tell my students, especially the ones that are learning algebra for the very first time, that this is one of the reasons that we learn algebra to begin with. You spend your entire first part of algebra learning how to put excuse me, your equations together, combine like terms, simplify as much as you can. Then we teach you this step of factoring and taking them apart. And the students think, why on earth are they making me take them apart after they spent so much time teaching me to put them together? Everything kind of comes together in this one lesson right here. You spend all of that time simplifying, getting things down to just a few simple terms. And then you notice, oh, I can factor this. And when you can factor that expression, it's going to give you the answer to a quadratic equation. So let me now get into this lesson. Quadratic equations, by definition, are polynomial equations in one variable that contain a variable that have a degree of 2 and no terms higher than that. So our biggest power is always going to be the power of 2. The standard form of a quadratic equation is considered to be ax squared plus bx plus c equals 0. You want everything to be all on one side of your equation, and you want your equation to be set equal to 0. A, b, and c should always be real numbers, and a should never be equal to 0, because if it is equal to 0, then that eliminates our quadratic term, and we're no longer dealing with a quadratic. We instead would be dealing with a linear equation. The ultimate goal of solving quadratic equations is to identify their roots. In other words, their solutions. To solve them, we're going to use what's called the zero factor property. Some teachers may also refer to this as the zero product property. And what the zero product property or the zero factor property says is that if A times B equals 0, then one of those two factors had to equal 0 to begin with. So either A was 0 or B was 0. That's the only way that we can achieve a product of 0, was if one or both of our original factors was 0. So we're going to use that zero factor property once we're all done factoring our quadratic to help us find the solutions or the roots sometimes even called the zeros, to our quadratic equation. Please know that these three words all refer to the answer of a quadratic equation. All right, so here we go. We're going to learn how to solve these problems. Please remember that the equations must always be in standard form. They have to be in the form of ax squared plus bx plus c, and they absolutely have to be set equal to 0. If they're not set equal to 0, then you need to manipulate that equation and move some terms around so that they are equal to 0. So what we do here is we take a look at what we're given. We have 3x squared plus 5x plus 2. Not a perfect square trinomial, so we are going to have to use the AC method in order to factor this. And in the AC method, we want factors that are going to multiply to 6 and add to positive 5. So we should use 2 and 3. They multiply to 6 and add to 5. Excuse me. So if you recall from the AC method, you bring down your quadratic term and you take your B term and you're going to split it into the factors that you've just identified. So I'm going to write 3x plus 2x and then bring down my positive 2 equals 0. I've just brought down everything else. So I split my 5x into 3x plus 2x and I brought everything else from my equation down. The next step in the AC method is to factor by grouping. So I'm going to throw some parentheses around my first two terms and my last two terms. We're now going to look for the GCF in 3x squared plus 3x. The GCF is 3x. So we're going to factor that out of that very first group, and when we do so, we're left with x plus 1. In my second group, the GCF is 2. When I factor that out, I'm left with x plus 1. And I'm going to bring down my equal 0. We check to make sure that the groups that we just created were identical. They were. So we're going to bring down that group. We have x plus 1. Our second group is created from what we had left over. So we have 3x plus 2 and bring down that equals 0. At this point, everything is completely factored. Excuse me. And those factors are set equal to 0. At this point, now that we have created two factors that are completely factored and set equal to 0, we're going to utilize the zero product property. And remember, the zero product property states that in order to have two factors, which our two factors are our two quantities, that equal 0, one or both of those quantities had to equal 0. So we are permitted at this point to take each one of those quantities, x plus 1, look at what I wrote, x plus 1, and set it equal to 0. And we're also permitted to take 3x plus 2 and set it equal to 0. Because remember, one or both of those factors had to have equaled 0 in order to get an answer of 0 on the right-hand side. So now we have two equations that we need to solve for x. So we're going to start by subtracting 1 from both sides here, and we'll see that this x is equal to -1. And for my second equation, we're going to subtract 2, and we have 3x equals -2, and then we divide by 3. So that x equals -2/3. So we just want to lastly write our answers as a solution set that says that x equals -1 or -2/3. And there is our final answer. Let's take a look at example 2. Example 2, we're going to do exactly the same thing. We're going to look at our quadratic and determine what type it is. Do we need to use the C method, the AC method, some other type of method? Take a minute, look at it, and see what you think. Okay, you should have determined that we need to use the C method for example 2. The AC method. So we're going to first start by multiplying A times C. So 2 times -7 makes -14. We want numbers that are going to multiply to -14 and add to the number that's in the position of B, which is +13. So what kinds of numbers are going to multiply to a negative yet add to a positive? Well, we could try 14 and -1. If we multiply those, we get right back to -14, and if we add them, we get to +13. So now we're going to use 2x squared plus 13x minus 7 equals 0. And we're going to split apart our 13x according to the factors that we just wrote. So we have 2x squared. I'm going to put the minus x first and the plus 14x second, just because for compatibility, I like it better that way. We're going to throw some parentheses around the first two terms and the last two terms. The GCF of my first group is x, so we're going to remove that. And we are left with 2x minus 1. My second group, I have 14x minus 7. My GCF here is 7. When I remove it, I'm left with 2x minus 1. I'm going to bring down my group of 2x minus 1. My second group will be x plus 7, and it still equals 0. At this point, we can use the zero product property to split apart our factors and set them equal to 0. So 2x minus 1 could have equaled 0, and x plus 7 could have equaled 0. Now we must solve each new equation for x. So we will add 1 to both sides. 2x equals 1. Divide both sides by 2, and x equals 1/2. For the second equation, we will subtract 7 from both sides, and x equals -7. So we have two solutions, and the two solutions there that we identified are -7 and 1/2. So we just want to write that as a solution set to show that x equals -7 and 1/2. Now, example 3. Remember, the equation must always be written in standard form, which is ax squared plus bx plus c equals 0. We have everything we need here except the plus c. You'll notice that not every equation will have the b term or even the c term. So your strategy here is to check for your GCF. Do we have a GCF? We do. In example 3, the first thing that we're going to do is take out the GCF of x. When we do that, we are left with 7x minus 3 in a quantity equals 0. We now have this equation as factored as it can get, and we have it split into two factors. So we can use the zero product property. The zero product property tells me to take each factor and set it equal to 0. So x equals 0 and 7x minus 3 equals 0. I don't have to do anything more for that equation, and for this one I have to add 3 to both sides. So 7x equals 3. Divide by 7, and x equals 3/7. So lastly, you're just going to write your solution set as x equals 0 and 3/7 to show the solutions, and you're finished. Example 4 is one where our ax squared and our bx and c are not on the same side of the equation. So we're going to have to manipulate this in order to get it on the same side of the equation. We learned in one of our previous chapters that we could move terms from one side of our equation to the other by utilizing addition and subtraction. And that's what we're going to need to do here. What we need to do is subtract 12 from both sides of our equation and add x to both sides of our equation. If we do that, that will cancel out the 12 and the x on the right side and move them over to the left side. So we will have x squared plus x minus 12 equals 0. We now have a quadratic equation that is in standard form and set equal to 0. So we can use the C method to find factors of negative 12 that are going to add to positive 1. If we use 4 and negative 3, those numbers will multiply to negative 12, and they will add to positive 1. Please remember that when we use the C method, we're permitted to simply create those two quantities right away, put our x's at the beginning of each quantity, and then use the factors as we found them. So one quantity will be x plus 4, the other quantity will be x minus 3, and they are still equal to 0. We can now use the zero product property and set each one of those factors equal to 0. So x plus 4 could have equaled 0, and x minus 3 could have equaled 0. And we now want to solve each little equation to find the value of x. So we'll subtract 4 from both sides. X equals negative 4. We'll add 3 to both sides. X equals 3. And our solution set then is x equals negative 4 and 3. Example 5 definitely does not appear to be in standard form. It contains our quadratic and our linear term are both contained in a numerator, and it's not set equal to 0. But we could pretty easily get this into standard form by eliminating that fraction to start. If we multiply both sides by 2, that will cancel the fraction out on the left-hand side. So we'll have x squared minus x equals 12. And then we simply have to subtract 12 from both sides to get it equal to 0. So we'll have x squared minus x minus 12 equals 0. Since the coefficient for my x squared term is positive 1, we can use the C method. So we want factors that will multiply to C and add to B. So I want to multiply to negative 12 and add to negative 1. We can use negative 4 and positive 3. In the C method, we're allowed to just create our groups, split our x, and use the factors that we identified. So we'll have x minus 4 and x plus 3 equals 0. We now want to use the zero product property to split apart our factors. So we'll have x minus 4 equals 0 and x plus 3 equals 0 and solve each equation for x. We will add 4 to both sides. X equals 4. We'll subtract 3 from both sides. X equals negative 3. So the solution set is x equals negative 3 and 4. The next section shows us that we can use quadratic equations to solve real-life problems. The first problem says that Carlos lives in Mexico City. He has a rectangular brick walkway in front of his house. The length of the walkway is 3 meters longer than twice the width. The area of the walkway is 44 square meters. Find the length and width of the rectangular walkway. Well, the first thing that I've noticed here is that length is based off of width. So that tells me that width is my starting point. So I'm going to let W represent my width. And then the second thing I'm going to do is write an expression in terms of W that can represent my length. So they told me that my length is 3 longer than twice the width. Twice the width is 2W, and 3 longer than that means I need to add 3. There's my length. The formula to find area is length times width. That's how we find area of a rectangle. If we picture what's going on here, my width is W, my length is 2W plus 3. Now, in order to find the area, we do want to use that formula, but the actual area was given to us. They told me that the area was 44 square meters. So now we just need to plug in the length and the width. So I'm going to have W times 2W plus 3. We want to start by distributing in that W to the quantity. So W times 2W gives us 2W squared, and W times 3 gives us 3W. We're following the order of operations. We've now created a quadratic equation, and we should be thinking, I should get my quadratic equation into standard form. To do so, we want to subtract 44 from both sides. 0 equals 2W squared plus 3W minus 44. We would want to check to see if there are any any GCF that we can factor out of there, and there's not. So since we can't factor that out, we want to set up the AC method. So I want factors that will multiply to AC but add to B. So 2 times negative 44 is negative 88. And I want my factors to multiply, or excuse me, to add to 3. Please take a moment and try to identify the factors that are going to multiply to negative 88, yet add to 3. From there, I would like you to finish factoring the equation, use the zero product property, and try to find the length and the width. Please press play as soon as you're ready to check your work. Okay, by now you should have had an opportunity to complete example 6. You should have found that if we use 11 and negative 8 as our factors, that will multiply to negative 88, yet add to 3. So from there, we would want to split up our B term into 2 new terms according to the factors that we just identified. So I'm going to take 3W and split it into negative 8W plus 11W, and then bring down my negative 44. And that should go right there. I'm running out of room. So we're going to throw some parentheses around the first 2 terms and the last 2 terms. And we want to identify the GCF of my first group, which is 2W squared minus 8W. We should see that we can factor out a 2W. That will leave us with W minus 4. In the next group, we can take out an 11. When I take out a positive 11, that is going to leave me with W minus 4. My groups were identical, so I'm going to go ahead and pull that group down to the next line and make a new group with what I had left over, which was 2W and positive 11. So my new group is 2W plus 11. We can now use the zero product property to split apart my groups and set each one equal to 0. We can solve. We're going to add 4 to both sides, so W equals 4. We're going to subtract 11. 2W equals negative 11. Divide by 2. W equals negative 5 halves. When we convert that to a mixed number, that is negative, not 5, negative 11 halves, excuse me, when we divide that, I'm jumping ahead of myself here, becomes negative 1 1/2. I apologize. Negative 1 1/2. We want to take that fraction of negative 11 halves and convert that to a mixed number and get negative 5 1/2. I'm getting way ahead of myself there. Okay, so we have 2 solutions so far. We have that W equals positive 4 and W equals negative 5 1/2. Being that this is a real world problem, you have to think about logic. Can you create a walkway that is negative 5 1/2 meters wide? The correct answer there would be no. Our measurements for a sidewalk would always have to be in positive units. So we would throw out that second answer since it's negative. We can't use it. So that means that the width has to be 4. We can then jump back and plug that 4 into the expression for length, which was 2w plus 3. So we'll have 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. So that tells us that the width was 11 and the width was 4 and the length was 11. So you have now found the dimensions of that rectangular walkway. Let's now take a look at example 7. The top of a local cable television tower has several small triangular reflectors. The area of each triangle is 49 square centimeters. The altitude of each triangle is 7 centimeters longer than the base. Find the altitude and the base of one triangle. The first thing that you should have recognized is that the altitude is based off of the base. So we're going to start by letting B represent the base, and then we can find the altitude once we know the base, because the altitude is 7 longer than the base. So we can let B plus 7 represent the altitude of that triangle. We were also given the area of the triangle, and we can plug that into the formula, which is 1/2 base times height. The height is exactly the same thing as a triangle's altitude. So they told us that the area was 49, so we're going to plug that in for A. And then we're going to plug in what we wrote for the base and the altitude. Our base is B. Our altitude is B plus 7. At this point, we want to simplify as much as we can. So we have 1/2 times, and I'm going to distribute in my B and get B squared plus 7B. I don't particularly want to work with a fraction, so at this point in time, I'm going to multiply both sides of my equation by my fraction's reciprocal, which is 2/1. When I multiply by the reciprocal, I cancel out that fraction, and on the left side I have B squared plus 7B, and on the right hand side 49 times 2 makes 98. Our equation is starting to represent a quadratic equation. We just have one more step to get it into standard form, and that is to subtract 98 from both sides so that one side of the equation equals 0. We now have a quadratic equation where the coefficient of my B squared term is 1. We can use the C method. So we want factors of C that are going to add to B. What kinds of numbers will multiply to -98 but add to 7? I would like for you to go ahead and finish this problem by finding the factors, factoring the equation, and finding the altitude and the base of the triangle. Please press play as soon as you're ready to review the answer. Okay, at this point you should have had time to solve example 7, and you should be ready to check your work with me. You should have found that positive 14 and -7 will multiply to -98 and add to positive 7 at the same time. When we use the C method, we're permitted to just throw those results right into parentheses. So our first group will be B plus 14, and the second group will be B minus 7. At this point, we can use the zero product property to separate out our results. So we'll have b plus 14 equals 0 and b minus 7 equals 0. We're going to subtract 14 to both sides and find that b equals negative 14. Add 7 to both sides and b equals 7. Think logically. We're talking about the base of a triangle. Can the base of a triangle be negative 14 centimeters? No, it can't. We cannot have a negative measurement for a triangle. So we're going to throw out that answer. We can't use it. Our base is going to have to be 7 centimeters. So then we can plug that back into our let statement for the altitude, where it was b plus 7. So 7 plus 7 will make 14. So that means that the altitude was 14 centimeters and our base was 7 centimeters. Example 8 deals with a tennis ball that's thrown upward with an initial velocity of 8 meters per second. Suppose that the initial height above the ground is 4 meters. At what time, t, would the ball hit the ground? This is an example of a vertical motion problem, and we can solve this using the formula S equals negative 5t squared plus vt plus h. T is going to represent time, v represents velocity, h represents the height above the ground that the ball was. So allowing our equation to be equal to 0, excuse me, and we're going to let s equal 0 because that is when the ball will hit the ground. That's what we're looking for there. We can plug into this equation with the information that we have been given. We were told that the initial velocity was 8 meters per second, so I'll plug that in for t. And the height above the ground when it was hit, that initial height was 4. So the initial height right here is always going to be what you plug in for your h. The s is going to be the height where it's ending. And since our ball is going to end on the ground, its height is 0. So now we're going to solve this equation using the methods that we have taught. We'll check for a GCF. There is none. So we're going to use the AC method. We want factors that will multiply to AC but add to B. So we have negative 5 and 4 for our AC. Negative 5 times 4 makes negative 20, but yet we have to add to 8. Please take a moment and solve this equation and find the factors of t. At this point, you should have had an opportunity to solve this equation. To find the factors of negative 20 that will add to 8, you should have used positive 10 and negative 2. So we're going to take our middle term, our t term, and split that into 10t minus 2t and bring down everything else. So we've brought down the 0 equals negative 5t squared. I split my 8t into 10t minus 2t, and I brought down my positive 4. We're going to go ahead and throw some parentheses around my first two and last two, and now we're going to factor by grouping. The GCF that I see is 5t. So I'm going to go ahead and take out 5t, which is going to leave me with negative t plus 2. My second group, my GCF, is 2. So I'm going to go ahead and take out a 2, which leaves me with negative t plus 2. My groups matched, so I'm okay to bring down my group, negative t plus 2, make my new group from what I had left over, 5t plus 2. And now that everything is entirely factored, I can use the zero product property to set my two factors equal to 0 and solve. So I have negative t plus 2 equals 0 and 5t plus 2 equals 0. We're going to subtract 2 from both sides. Negative t equals negative 2. Divide by negative 1, and t equals 2. We're going to subtract 2 from both sides. 5t equals negative 2. Divide both sides by 5, and t equals negative 2/5. We need to use our logic again here. It says at what time did the ball hit the ground? If time was 0 when we started, does time go backwards to be negative? Do we ever measure time in negative units? The correct answer there is no. So we have to throw out our negative answer. We can't use it. So the answer that we will use, however, is t equals 2. So the answer to this problem is that after 2 seconds, the ball will hit the ground once it is thrown from a height of 4 meters with an initial velocity of 8 meters per second. So we can just write here that the time equals 2 seconds. We have one more problem here for us to solve, and it is student practice number 8. I would like for you to go ahead and solve this one. We're going to use exactly the same formula that we used in our previous example. We're going to use S equals negative 5t squared plus vt plus h. Please go ahead and take a second to plug in, try to get your equation in standard form, find a way to factor it, and see what you come up with. When you are ready, please go ahead and press play, and we will go over the answer together. Okay, everyone, let's see what you've come up with for this one. As you're setting this problem up and reading through it, our diver is going to hit the ocean water, so his ending height will be 0. We have negative 5t squared. His initial velocity is 0 because he's free falling, and his height above the ground is 45 meters. So at this point, we are now going to work on solving this equation using factoring. So let's get this simplified. We have negative 5t squared. 0 times t makes 0. So we now have plus 45. I've taught you to factor out a GCF. So hopefully you did that. I'm going to factor out a negative 5. When I do so, I'm going to be left with t squared minus 9. You should notice that t squared minus 9 is a difference of 2 squares. I'm going to show you a little trick really fast though. I'm going to divide both sides by -5. That cancels that out and still creates 0 on the left-hand side. So now, all I have is my difference of squares. So we're going to go ahead and factor that. We take the square root of the first term, which is t, the square root of my last term, which is 3. One group gets a plus, one group gets a minus. I now have my equation completely factored, and it is completely set equal to 0. So I can use the zero product property to split those apart. So t plus 3 could equal 0, t minus 3 could equal 0. I'm going to subtract 3 from both sides. So t could equal -3. I'm going to add 3 to both sides, and t could equal +3. Even though they're both solutions to my equation, they're not both solutions to my problem. So I have to throw out my negative answer because time cannot be negative. That means that it took our diver 3 seconds to free fall 45 meters to the ocean. If you have any questions at all about how to solve a quadratic equation using factoring, please feel free to contact me, and I will be more than happy to work with you on this section. Thank you.